The digital camera revolution brought cinematic quality to the masses. It did away with the many expenses involved with shooting and developing film. But it introduced a whole new discipline in filmmaking: data wrangling, or the art of the DIT. Management, storage, and transfer of digital bits of information has replaced the handling of celluloid reels, and mismanagement can be catastrophic. In this set of videos, we'll take a look at procedures for acquiring your footage safely, offloading camera cards for reuse, transferring, storing, transcoding, and the power and pain of offline editing. Now, back in the days when celluloid film productions were commonplace, there was a saying on video shoots that tape is cheap, meaning that since the crew was shooting with affordable videotape stock and not film, you could afford to shoot longer and lazier. You could argue that's even more the case with digital, since camera media can be recycled simply by dumping the captured clips to a drive and reformatting. But tape is cheap was only ever a half-truth. Media is exactly as valuable as the footage stored on it. If your card stores 5 hours of selfies, that's one kind of value. But if it holds the results of a $250,000 shoot day, well, now all of a sudden it's a very expensive sliver of plastic and silicon. So let's start with a look at the card itself. Rule number 1: don't buy a cheap card. Many of us do this once, but only once. A cheap memory card might be fine for casual vacation stills, but for demanding video work, you're almost guaranteed to end up with dropped frames and corrupt files. Rule number 2: buy a card with more speed than you need. Most video capture codecs publish their data rates, or you can search for the numbers on the web. Even if you only plan on shooting in a compressed 422 codec, we'll talk about codecs a little later, buy a card that can handle the demands of shooting RAW, since the day after you buy the card, you may well discover your shooting requirements have changed. Before we leave Rule 2, we need to talk about what card speed really means. The faster a card, the more data you can push to it per second. The problem is, there are two main ways to measure card speed. One is burst speed, the other is sustained. The marketing folk love to talk about the burst rates, since they're the most impressive. For still photographers, that might have real value, but for video work, we care very much about how fast a memory card can move data at a sustained rate. Make sure the sustained rate of the card exceeds the highest data rate supported by your camera. And don't get your bits and bytes confused. There are 8 bits, small b, to a byte, capital B. So if your codec records at a data rate of 22 megabytes, big B, and a memory card advertises a sustained data rate of 160 megabits, small b, you'll need to divide those bits by 8 to get the megabytes. For a 160 megabit card, that works out to 20 megabytes, too slow for your 22 megabyte codec. Rule number 3. For staged productions, choose speed over capacity. For interview and documentary productions, choose capacity over speed. On a staged production, you can always swap, transfer, and reformat data, so it's better to spend the money on a speedy card. For documentaries and the like, there's nothing worse than running out of recording time right when the critical moment happens. Rule number 4. Always have at least one backup. Ideally, we recommend a minimum of 3 cards per camera. 2 cards will alternate on the shoot, and a third sits snugly in a case somewhere for the off chance that there are problems with one of the active cards. Rule number 5. Obey rule number 1 at all costs. Again, the value of your card is equivalent to the cost of the entire shoot. If your card fails to capture the scene, then the entire shoot was for nothing. Rule number 5.5. In a perfect world, capture both to a card in the camera and a digital recorder like one from the Adamus line of monitor recorders. That way you have a redundant capture if your main card fails. Once you've got your cards, you need to decide what codec and format you're going to record to. Codecs are basically different ways of encoding and decoding pixel data to squeeze the data into a smaller space on your memory card or hard drive. The codec landscape is a constantly changing one, so we're not going to delve into specific flavors here. But there are a couple of guidelines. Firstly, make sure the codec can hold enough dynamic range to match the quality of your camera sensor. If your camera can catch 16 stops of exposure, but you're using a 10-bit linear codec, you're going to lose a lot of contrast detail when the data is compressed. Now, a 10-bit log codec will fare much better. You'll need to do a little research with respect to your camera and the recommended codec for taking advantage of its dynamic range. Secondly, if you're shooting visual effects, shoot at the highest quality possible. In fact, if you're shooting your movie with a DSLR, you may want to think about renting or borrowing another camera for VFX shots. You see, the human eye is very forgiving about the detail and colors falling outside the free spectrum of light, from which around 59% of our sense of contrast is derived. So, modern codecs will often throw out spatial detail in color information where the human eye won't really miss it. This is roughly the basis behind color spaces like 422. 422 will give half the spatial quality in the chrominance subcarrier components of a signal as compared with the luminance channel. But when it comes to VFX work, it doesn't matter whether it looks right. The visual effects software needs all the detail it can get for tracking pixels, keying green screens, or creating virtual 3D environments. So when doing VFX, shoot in the least compressed format available on your camera, which usually means RAW. Before we close the discussion of memory cards, one quick note on formatting. Some cameras will give multiple format options. We recommend avoiding the exFAT file system if that's an option given. It's convenient since it's easily readable by both Macs and PCs, but it's not a journaling format, so it's more susceptible to corruption. Let's discuss on-set workflow. As we mentioned, you want at least 2 cards per camera. Once one is getting close to full, or at the commence of any crew breaks, swap the cards. You should adopt a clear naming convention. If the main camera is called Camera A, name its first card of the production A001, then A002 for the second, and so on. Get in the habit of including those leading zeros. They'll help in later alphabetical searches on the hard drive. It's imperative that you rename each card. It'll avoid a lot of confusion in post. Of course, as you cycle between 2 cards, the same physical card will be called A01 the first time it's used, then A03 the next time, and so on. To transfer the data off a camera card, you want a high-speed card reader. Time is critical, so you don't want everything to slow down because your card reader takes an hour to copy 10 minutes of footage. 2 things affect the speed of a card reader: its rated speed and the speed of the bus it's connected to. For example, if you have a card reader capable of 1 gigabits per second data transfer, but it's connected to your computer via an older USB 2.0 bus, you're likely to tap out the transfer at about 320 megabits per second, the typical maximum transfer for USB 2. So get a high-speed card reader and make sure it connects to an on-set workstation or laptop via the fastest interface on that computer. Next, we need to decide on a storage drive to transfer the card's data to. This is another area where you can't afford to be cheap. A redundant RAID drive is a must. We don't have time to discuss RAID levels here, but a RAID level of 1, 5, or 6 is a good choice. Now here's an important point. If you can afford to keep enough cards on set, don't recycle cards. Instead, replace each full card with a new one. You'll still back up to a RAID drive, as we'll discuss in a moment, but with extra cards, you can keep each card as an additional security backup right through the post-process. Alas, many budgets can't afford this, and so cycling between 2 or more cards is common. In this case, The preferred backup drive method is to copy the cards to 2 drives at once. That way, an identical copy of the data can be transferred to both drives. Why separate drives? Because if a careless PA accidentally drops one off the side of the building during Spider-Man's big stunt sequence, the other drive won't die with it. Well, hopefully. The best solution is to use dedicated offloading software like ShotPut Pro. It'll automate the transfers, drive mirroring, and verification for you. Without dedicated software, you'll need to RAID your drives together in RAID 1 configuration to get cards copied to 2 drives at once. Your system should also include a UPS battery backup for the drives. A power failure while media is copying can occasionally cause corruption or even permanent damage to the backup drive. A UPS will minimize the risk of things ending poorly if someone trips over the power cable or the power goes out. Okay, so after each card becomes full during shooting, you'll back it up to the RAID drives. After the content of a card has been verified as backed up to both drives, it's safe to reformat. A good idea is to wrap the card in colored paper tape to confirm that it's ready to be reformatted. That'll avoid accidental erasure of cards that have not been backed up. Be sure to create a folder structure on the RAID that clearly identifies the production, the date of the shoot, and each camera on the shoot as seen here. When creating date folders, lead with year, then month, then day for correct chronological sorting in alphabetical order. Each card's entire contents should be placed in a folder labeled with both the camera it was capturing from and a unique identifier for that card. Typically, the card number will increment each time a new card is used in the camera, independent of the day of shooting. So if the last card on day 3 was A009, the first card on day 4 will be A010. You'll also have a sound folder for any dedicated audio sources. Create a separate folder for each sound source. Don't rely on the folder structure to keep everything ordered. If the card's files get moved to another drive, you'll want to make sure they can be easily identified, hence the inclusion of the camera's letter in the card's folder name. Now, inevitably, you'll end up with problems. Perhaps one of the audio sources failed to capture, or both A and B were recorded on the same card due to an emergency on set. In such cases, be sure to include a README text file in the relevant folder explaining the situation. This will save editorial a lot of headaches trying to track down files that never existed. When files are done copying, you need to check the data. If you're using dedicated data wrangling software, it'll most likely include verification tools. If not, compare the total data size of the source card and the destination folders to make sure they're close to the same. Due to drive formatting differences, there may be a minor delta in file size. Also, check that the folders contain identical numbers of files. Finally, skim through the source media clips on the backup drives to make sure they appear to be intact and play without glitches. For many formats, you can review in a media player like QuickTime Player. For other formats, you may need to fire up a nonlinear editor and preview there. If you're cycling cards, you can then reformat the card ready for reuse. If you're going to format the cards on your laptop, do some tests before the shoot to ensure that the camera you're shooting with is happy with cards that have been formatted that way. Typically, though, the best place to perform formatting is in the camera that's going to use the card. And remember to wrap them in color-coded paper tape to indicate that they're ready to reformat. Let's talk about dailies. The term dailies, often referred to as rushes in European productions, originated in the days of film production when film from a day of shooting was developed and telecinied to video for review by the director the following morning. The era of digital production has radically improved on-set review, since footage is instantly available for review at a video village immediately after it's been shot. However, there's still a need for distributing dailies for general viewing by directors, producers, and editors off-site. For such purposes, the video footage needs to be transcoded into a different digital video format for ease of distribution. As with acquisition, we can't cover all the details of codec and format choice, but here are some pointers. 1. Consider resizing the video. This is especially true for 4K formats like Ultra HD. In most cases, people reviewing dailies are concerned with the general content and framing, not pristine visual resolution, so a pixel size of 960 by 540 is usually more than enough visual resolution for dailies. 2. Avoid dual-pass variable bitrate encoding. Dual-pass encoding provides the best quality for the data size when compressing video, but it's molasses slow. Better to encode with a very rudimentary variable bitrate or constant bitrate and get the files completed in a timely manner. It may not be as great in terms of quality, but with dailies, getting footage into people's hands on time is typically the most important priority. 3. Run the numbers before you start encoding. A video codec with a compression rate of 30 megabits per second may be fine for a 2-minute clip, but for 20 minutes of footage, you're looking at 4.5 gigabytes of data. That could bring your uploads to a crashing halt if you're on a modest internet connection. 4. Create a test clip before the shoot to make sure the compression format you choose works for the kind of footage you'll be capturing. Content where there's a lot of movement in the frame will require a higher data rate than something like a talking head. There's nothing worse than sending a blocky video for someone to review, so make sure you test encode footage with similar resolution and motion to what you're shooting. 5. Choose a conservative format that you know will play on anyone's computer. Assume the person that will be watching the dailies has no tech savvy whatsoever. They need to be able to click and play. So choose a common, reliable format like MP4 as the playback format. Emerging standards may work in some places, not others, so steer clear of anything that hasn't been in the market for a couple of years. Security is another issue. If you're working on a high-profile project, you don't want to risk even dailies being intercepted and distributed. So in such cases, be aware that part of transcoding may involve watermarking and encryption. Okay, so you're on the shoot and you want to get your editor started immediately. Unless you have big, fat drives to ship overnight, you'll want to create additional files for offline editing that can be uploaded over the web or sent on a single rugged drive. In offline editing, lower quality versions of footage are used for the base edit and later replaced with the full quality versions. Like creating dailies, you'll want compressed versions of all the clips for the editor, but the requirements are actually quite different. For starters, you'll want a video codec that's easy to edit with. Codecs that compress well may actually require a lot of effort for your computer to decode. And codecs with long GOP structures, that's a story for another day, can make frame-accurate editing difficult. So go with a codec that's a standard for your editing system, like ProRes, DNxHD, or DNxHR. But probably the most critical aspect of preparing media for offline editing is preservation of timecode. You see, to online the full quality versions of the clips later, we need to make sure the offline versions match frame for frame. For consumer formats like DSLR, this can be a problem. Such formats don't embed actual timecode and simply measure time from the start of each clip. So you'll want to test your pipeline to make sure your editor can relink high-quality media after editing with the offline media. Whatever the case, it's important to keep the file names of the offline media matched to the original high-resolution media. As far as resolution goes, like dailies, a resolution of around 960 by 540 is usually sufficient for making editorial decisions during an offline edit. What you may not want to compromise, though, is color resolution. If your editor is likely to create a base grade during the edit, you want to keep the bit depth and color space subsampling the same in your offline video as it is in the online. More and more, editors are also finishing color on independent features and episodic television, so color fidelity in offline media is important. Let's review. Use cards that are fast enough to handle the highest data rate your camera can record at. Choose a capture codec that can handle the dynamic range and resolution you need for production. For visual effects, shoot at the highest quality possible. Use a naming convention that clearly identifies the camera and the order of shooting. Use a high-speed card reader for transfers. Back up to at least 2 physical drives to ensure redundancy. Create a clearly named folder structure for easy identification of files in post. Be sure to verify transfers before wiping cards, and use colored tape to indicate cards that have been backed up and are ready to be reused. For dailies, resize to 960 by 540 or less and use a small, consumer-friendly codec for ease of upload and delivery. And for offline editing, avoid long-op codecs and test your editing software's ability to relink to the source footage before commencing the offline edit.